Reality has a limit, but not the kind you think. The opposite is also true. Reality refuses the very idea of a limit in the classical sense. Both statements are profound. Both resist each other, and yet I spent my life discovering that both must be held simultaneously if we are to understand anything at all about the nature of existence. Let me take you to Copenhagen, to those long winter evenings at the Institute when we first began to see that nature herself refuses to answer certain questions. Not because we lack the instruments, not because we haven't been clever enough, but because the questions themselves dissolve upon inspection, like shadows cast by language onto a world that will not cooperate with our categories. You want to know where the electron is? A reasonable question. Classical thinking says it must be somewhere, moving along some path, possessing definite properties whether we look or not. Reality, it turns out, does not share this assumption. I remember the night Heisenberg came to me, troubled. His mathematics was telling him something strange. The more precisely you determine a particle's position, the less you can know about its momentum, not as a practical limitation, as a fundamental feature woven into the fabric of existence itself. We sat in that dim office, and I felt the ground shift beneath classical physics. Perhaps, I thought, we have been asking the wrong kind of question all along. Consider what happens when you observe. You cannot watch reality without touching it. To see an electron, you must bounce a photon off it. But that photon carries energy, momentum. It disturbs what you are trying to observe. Make the photon gentler to minimize disturbance, and its wavelength grows longer, blurring your ability to locate the electron precisely. Use a shorter wavelength for precision, and the photon kicks harder, scrambling the electron's momentum. This is not a technical problem waiting for better equipment. This is nature saying, you may know this, or you may know that, but the act of knowing one erases the possibility of knowing the other. And yet, perhaps this runs even deeper than measurement techniques. Perhaps the electron does not possess both definite position and definite momentum before measurement. Perhaps these properties exist only in relationship to how we interrogate nature. The question, where is it and how fast is it moving, may be asking for something nature does not provide, like asking what color Wednesday tastes like. One might say, surely the electron is somewhere doing something, whether we look or not. Einstein said this to me many times with great passion. God does not play dice with the universe, he insisted. And I understood his discomfort. It pained me to oppose my hero. But I had to reply, Einstein, stop telling God what to do. Because what we discovered in Copenhagen was not that reality is random in the sense of chaotic. We discovered that reality is contextual. The electron's properties emerge through interaction with measuring apparatus, with conscious observation, with the asking of questions. Change the question, change the apparatus, and you change what properties manifest. This is complementarity. Not sometimes a wave, sometimes a particle. Not hidden variables we haven't found yet, but fundamentally, irreducibly both. Which aspect manifests depends entirely on how you choose to look. The wave description and particle description are each necessary, each complete within their domain, and completely, irreconcilably incompatible with each other. Reality has two faces that cannot be seen simultaneously. In those long debates at the Institute, we would pace the halls asking, where is the limit exactly? Is it in our instruments? In our mathematics? In human consciousness itself? And slowly, reluctantly, we came to see the limit is in reality's relationship to description. Physics does not describe nature as it is in itself, independent of observation. Physics describes only what we can say about nature when we interact with it. And nature has opinions about what can be said. There are questions that sound perfectly reasonable, but turn out to be physically meaningless. What is the electron doing between measurements? Classical thinking demands an answer. Nature refuses to provide one. Not because the answer is hidden, because before measurement there is no fact of the matter to be discovered. The electron does not travel any particular path between emission and detection. It does not possess definite properties awaiting revelation. The quantum state is not a description of ignorance about underlying reality. It is a complete description of a reality that exists in superposition, all possibilities coexisting until observation collapses them into actuality. This is the limit. You cannot access the quantum system's properties before measurement in a classical sense. The very act of measurement participates in creating the properties you find. Or so it seems to me. And yet I am comfortable with uncertainty here. Perhaps even my description fails. Language evolved to describe medium-sized objects moving at medium speeds through three-dimensional space. When we venture into the quantum realm, our words slip through conceptual nets like water through fingers. But deeper still, Bohr's interpretation suggests reality itself places a limit on the kind of questions physics is allowed to answer. Not because physicists are timid, because nature draws boundaries around meaningful inquiry. You can ask, what will we observe if we measure this electron's position with this apparatus at this moment? Nature provides an answer, probabilistic but precise. You cannot ask, what position and momentum does the electron really have, independent of any measurement? Nature does not recognize the question. It is like asking what happens north of the North Pole. The question contains assumptions about reality's structure that reality herself does not honor. I know how this sounds. It sounds like retreat. Einstein felt this keenly. He believed quantum mechanics was incomplete, that beneath the probabilistic surface lay deterministic machinery we simply hadn't uncovered. Hidden variables, he thought, would restore classical causality. But I cannot agree. The limit is not temporary ignorance. The limit is final. Quantum mechanics is not waiting for completion by some deeper theory. It is complete within its domain because it describes the limits of what can be described. Trying to go beyond these limits is not ambitious physics. It is conceptual confusion, asking what color a sound is, what flavor geometry has. And yet the paradox deepens. If measurement creates properties rather than revealing them, where do we draw the boundary between observer and observed? When does the quantum superposition collapse into classical definiteness? When the photon hits the electron? When it strikes the detector? When the detector's reading reaches human consciousness? We do not know. The measurement problem, I must confess, haunts me still. Perhaps there is no sharp boundary. Perhaps observer and observed are entangled in ways that resist separation. Subject and object dissolve into a unified system that cannot be cleanly divided. We are not outside nature looking in. We are inside, participating, our observations woven into the fabric of what becomes real. This creates a strange loop. We observe reality, but we are made of the same quantum stuff we observe. The observer is part of the observed system. How then to make sense of observation itself? I do not have an answer, but I have learned that not having an answer can be a kind of wisdom. Reality refuses a complete, unified picture. It forces us to use different, incompatible frameworks depending on what questions we ask. The limit is not on speed, as in relativity, not on energy or size. The limit is on conceptual completeness itself. Nature will not be captured by any single description, no matter how mathematically perfect. She requires multiple contradictory descriptions: wave and particle, continuous and discrete, deterministic and probabilistic, each true in its context, each failing when pushed beyond its domain. In my office I have the symbol of yin and yang, chosen for my coat of arms when Denmark honored me. Opposites that require each other: light and dark, wave and particle, knowledge and uncertainty. The ancient Eastern philosophers understood something the West is only now discovering. Profound truths come in complementary pairs. The opposite of a trivial truth is false, but the opposite of a profound truth is also a profound truth. So why does reality have a limit? Perhaps because reality is not an object existing independently, waiting to be discovered. Perhaps reality is relational, existing only in the dance between observer and observed, in the questions we ask and how we ask them. The limit is not imposed from outside. The limit emerges from reality's relational nature. There is no view from nowhere. Every observation is from somewhere, with some apparatus, asking some specific question. And each vantage point reveals only certain aspects, necessarily concealing others. This is not pessimism. This is liberation. We are freed from the impossible task of grasping reality as it is in itself, independent of interaction. Instead, we engage with reality as it shows itself to us, contextual, responsive, participatory. Walk through Copenhagen in winter twilight and you will see what I mean. Is the light wave or particle? The question dissolves. Light is light. Our descriptions are complementary approximations, each capturing something true, none capturing everything. In the quantum realm, we discovered that nature is stranger and more subtle than classical physics imagined, but also more beautiful. The uncertainty is not a bug, it is a feature, perhaps the deepest feature of existence. Where does this leave us? Staring at a reality that refuses complete description, that changes under observation, that exists in superposition until measured, that draws boundaries around meaningful questions. Some find this disturbing. Einstein did, to his last days. He wanted a cosmos of deterministic clockwork, God's thoughts made mechanical. He wanted reality independent of observers, properties defined whether measured or not. But I found peace in complementarity, peace in accepting that full knowledge may be impossible not because we are limited, but because fullness itself is an incoherent demand to place on quantum reality. We are both spectators and actors in the great drama of existence. Our observations do not merely reveal what was always there, they participate in bringing forth what becomes definite from what was potential. Perhaps this is the final surprise. The limit is not on reality. The limit is on the very idea of reality as something separate from our investigation of it. One might ask, then what is there, really, beneath all our observations and measurements and questions? One might also ask, is that question itself meaningful? I do not know. I am comfortable not knowing. The mystery remains, hanging like a particle in superposition, refusing to collapse into certainty. And perhaps that is as it should be.